Welcome back to my math calculus 3 homework video where I will be solving two questions today. We'll be doing number 3 and 4. One is finding the tangent plane and the other is finding the area. So finding the tangent plane of the vector function v cosine u v sine u v squared, where v is greater than or equal to less than or where it is greater than or equal to 0 and it wants the plane at the point of 1 square root of 3, 4. Now, I have no idea what this graphs. It could be a funky shape like that, but the tangent plane, we're going to take the partials for v and u, and that will create a normal vector, and with that normal vector and the point, we can create a surface plane, which is what we are solving. So if we take the partials for u using that, the magnitude r of u cross r of v equals the normal vector, where then there's a lot going on where it gives us a vector, but then we have to find what u and v are, so we can find that right now, where if we look at the point in v, since v is squared and v is also greater than 0, that means that v equals 2 and u, if we look square root of 3, so we would want the sign to be square root of 3 over 2, which, let's see, that's equal to 1/3 pi. So, 2 times square root of 3 over 2 would give you square root of 3. Okay, now we have everything that we need to solve. So we're going to find r of u and r of v, cross them, get the normal vector, plug in the 2 points, and then that will give us a vector, which then we have the vector, we have the point, and we can make the formula. So r of u equals, v stays, so just be negative v sine u, that goes to cosine, and there is no u, so that's a 0, and r of v is, that's pretty simple. There's a 1, 1, and then 2v. So cosine u, sine u, and 2v. And then we must cross. The only way to solve is by crossing. There's probably other ways to solve, but the only one off the top of my head is to cross. So that's going to be 2v squared cosine u minus 0, and that's negative 2v squared sine u, and that's going to be 0 yet again. And then now this is special. If we look here, when we multiply this across, we're going to get negative v sine squared, and we're going to subtract this one, which is also going to be negative v cosine of u squared. So sine squared plus cosine squared is 1, so we'll just skip to that step and just do negative v. So if we simplify 2v squared cosine u squared sine u and negative v, and we plug in the points of 2, 1/3 pi, then we get 2, that will be 1 over square root, no, 1 over 2, so 2 times 4, 8 times 1/2, that would be 4, so that's 8, and that is square root of 3 over 2, so that's 4 root 3, and that's just negative 2. So this is groundbreaking. We have the vector direction of the normal vector, and we have a point, so we can now go into the tangent plane formula of 4x minus 1 plus 4 square root of 3 y minus square root of 3 minus 2z minus 4 2, okay, so that's x minus 4 plus 4 square root 3y. Now multiplying those two will give you 3, so 3 times 12 is 12, so that's minus 12 minus 2z plus 8. So minus 4 16 plus 8 negative 8. So it's x plus 4 square root of 3 y 4x minus 2z equals 8. And that is how to solve the tangent plane. We will now be solving the area of a plane on a circle. So much better, more professional, more profound. And that will be r of uv equals u plus v, u minus v, and u, where u squared plus v squared is less than or equal to 1. And we can find the surface area using u cross r d dA. We will use that to find that. Now the area that we are trying to find is a plane, and that is a circle. So if we take the circle and project it onto the plane, we'll get something like that. So we're finding an oval basically. So r of u is 1, 1, 1. R of v is 1, negative 1, and 0. And then we just start crossing the best part of math. So 1 times 0, negative, plus 1, and then 0, minus 1, and that'll be negative 1, and it will be subtracted by 1, so it'd be negative minus 1. So if we simplify, that gives us 1, 1, negative 2. Now, this says to take the magnitude, so 1 squared plus 1 squared plus negative 2 squared. That will give us square root of 6, and we want to take the double integral. So since this is a circle, we may as well go to polar, where this will be r, and it does a 2 pi rotation. Now this is real nice. If we look here, we have u squared plus v squared equals less than or equal to 1. Now this looks familiar, since x squared plus y squared equals r squared. We'll just treat it in the same property. So r squared is less than or equal to 1. So we will be integrating from 0 to 1. So square root of 6 r dr d theta from 0 to 1, 0 to 2 pi. Now we do have an r out there, so when we integrate it, we'll get square root of 6 over 2 r squared from 0 to 1. But the 0, r is 0 would be 0, and r is 1 would just be 1. So we have from 0 to 2 pi square root of 6 over 2 d theta. Now there's no theta, so we can just throw in a theta over 2 theta from 0 to 2 pi. Again, 0 as theta would make it 0, and once we go in 2 pi, square root of 6 over 2, the 2's cancel, and that leaves us with an area of square root of 6 times pi. And this is the final answer and the area of that circle. There you go. Now you know.